As we've entered into proofs in our class, there are certain properties that are assumed based on equality. And these ones are ones that we don't necessarily have to prove any longer. We just get to cite them based on the fact that they're properties. And so today, as you're writing these down, you're going to want to stop and pause, take like little snapshot captions of each of the examples and their meanings and what the words are, and put this in a place where you can reference it regularly because you're going to be using it quite frequently from here on out. I'm going to go fairly quickly just to save time on the length of the video, so at any point where you need to catch up, please press pause and then press play again when you're ready. Okay? So the first word that we're looking at is called the reflexive property, and basically what the reflexive property is saying is that a quantity is equal to itself. Is equal to itself. And so this hopefully makes sense because 2 should equal 2, 3 equals 3, but any segment should equal the length of itself. So segment AB is equal to segment AB. Very useful. You can use it at any time as long as you have a segment or an angle. Then you can use it to add or subtract from that. The transitive property is something that you guys have really experienced through substitution for your whole entire mathematics careers. But here's basically the wording of it. If two quantities are equal to the same quantity. And you can see this kind of with my green circle. So I have AB equal to BC. I also have EF equal to BC. So BC is the similar quantity. Then they are equal to each other. And we've used substitution for this for a long time. The symmetric property, you just kind of are able to reverse the order that you're writing things. So if a quantity is equal to a second quantity, then the second quantity is equal to the first quantity. And so you've got this, symmetry, but this ability to rewrite it in either order is essentially what they're saying. Now, the next ones you've used for a very, very long time, since algebra began for you, but an addition property is basically if I have equals, I can add equals to them. So if equal, and that's really the important part, is they have to be equal, quantities are added to equal quantities, then their sums are equal. And so basically I'm just able to add equals to equals and maintain equality. Really important as we get into segments and angle additions. Subtraction property of equality. The way they word this is basically that you started off with two things being equal. And then they tell you that you have an equal amount, so they're subtracting these equal pieces. And basically what it does is it prevents you from having to do a lot of substitution. You could substitute in BC on this side, then subtract BC from both expressions. And that's a really long way, so they're trying to shortcut this for you. So if equal quantities are subtracted from equal quantities, the differences are equal. Okay, 3 more. Multiplication property of equality. We start off with equal angles. And if you multiply by the same number, it could be a 2, a 3, a 4, an x, a z, as long as they're the same thing, your product should be equal. So if equal quantities, and you have used this when you were solving in algebra for a very, very long time. If equals are multiplied by equal quantities, the products will be equal. Similarly, if equal quantities are divided by equal quantities, then the quotients are equal. And finally, substitution is really nice. A quantity, it may be substituted for its equal. It's got a little broader use than the transitive property, but it's very, very similar. Okay, again, make sure you summarize each of these. A lot of vocabulary. You're going to use these regularly for the rest of the year when you're doing proofs, so make sure that you have them in a safe place where you'll never lose them, maybe in the back of your notebook as you're creating like a glossary of terms. Thank you.